Alrighty, right-hand rules 101. So there are a couple of right-hand rules. So our first one you've seen is our physics gang sign, basically. Anytime you have a cross product, your pointer finger is the first vector, your middle finger is the second vector, and your thumb is the resultant. So you make like the loser sign and then stick your little middle finger out. Wow. Okay, so in this case, F equals QV cross B. My first vector is Q times V. So if I have a nice little plus sign moving to the right, that would be this way. My second vector is B, that's my middle finger. My B field is into the page, that's what my little X's mean. So QV cross B into the page is going to give me a force going upwards. So my force is going upwards. So this little dude is going to start being deflected upwards. So as he gets deflected upwards, his force is going to rotate with that. So charged particles moving in a magnetic field are going to end up making circular paths. Similarly, we can use this for our force on a current carrying wire. So F equals IL cross B. So our first vector is IL, that's going to be our pointer finger. In this case, my I is pointing to the right. IL cross B, my B is into the page again. So this wire is going to feel a force upwards. So those are our two examples of our right-hand rule with this one. So you can actually use this for any cross product. It doesn't just have to be in physics. You can use it in math class or some engineering classes too. First vector, second vector, resultant. Alright, so now we also have our right-hand rules of determining the direction of magnetic fields caused by current carrying wires. So the two most prominent examples of this are a straight wire and our ring of wire. So this one, we use this right-hand rule. So your thumb is the current and your fingers are the direction of the field. So for this case, my thumb is the current and my fingers curl around like this. So everywhere to the right of this wire, my field is going to be going into the page, and everywhere on the left of the wire, my field is going to be coming out of the page. So from a top view, my magnetic field makes concentric circles around my wire. So out of the page, curly cues tell me which direction the field goes. With our current carrying wire, we can do the same thing. So if I follow the current with my thumb, it's wrapping around. So at the center here, this is going to be out of the page. You can also interchange B and I with your rule. So if my current is curling in a circle this way, my field is coming out of the page. So I like this one because B and I, you can switch which one is which, unlike this one. So if your current is moving in circles, your field is pointing that way, but if your current is the straight thing, then your field is pointing that way. Hopefully that helped clear that up.